Okay, well, welcome everybody. We're 12:04, so we'll get started, and whoever's joining us can still join. My name is Andrea Zapp. I'm with Aquatic Sensors, and I work from the Ontario, Canada office, and we're very happy to be here with our partners, ANB Sensors. I'm just going to hand it over to my colleague Patrick to introduce himself.
All right. Hello, everyone. I'm Patrick Sanders. I'm with the California, USA office for Aquatic Sensors. We're really excited to introduce you guys to ANB Sensors today. We have been with these guys at various conferences over the past few months, and their technology has been very well received. And so we're really excited to be able to kind of show this technology in more depth to you guys on this webinar. So that being said, I'll pass it back to you, Andrea.
Okay, awesome. Thank you. So just a quick housekeeping, as I was saying before, if you put it into speaker mode, you'll be able to see Nathan do his demos with better optics. And if you're not speaking, if everybody just wants to keep themselves on mute because we're recording, and it'll give everybody who can't be here today a good view of the recording. We will have time at the end. We'll do about 30-35 minutes of a demo that's going to be broken up into maybe 1 or 2 sections and some presentations about technical specs and key benefits. And then we're going to do at least half an hour of Q&A, so you can ask away all your questions that you're dying to ask Nathan. And what else? Yeah, so it'll be an hour, and if you have to, if you want to stay longer, we're here for you. So feel free to stay past the hour if you have more questions. So without further ado, I am going to introduce the technology of the hour, and I'll start with the 2 gentlemen on here that are going to be doing most of the talking. So let me start with Dr. Nathan Lawrence. He is the CEO of ANB Sensors that has developed the next generation pH sensors for oceanographic and water quality monitoring. Before ANB, he was the program manager and a principal research scientist at Schlumberger Gold Research, and he did his postdoc at New Mexico State University and completed his PhD at Oxford University. Nathan is also a fellow of the Royal Society of Chemistry, has authored 130 research papers, and co-authored a chemistry textbook. I could go on about his many achievements, awards, and inventions, but I'm just going to drop them in the chat so you can read them at your leisure. And now I will introduce the next force on the team, which is Mark Pritchard. He is the CCO for ANB Sensors and has a strong history of establishing and scaling businesses on a global scale, coupled with numerous successful new product launches. He is the driving force to bringing awareness of the next generation pH sensor for ANB Sensors. So as I mentioned, I believe we are going to start off with Nathan doing the demo. Nathan, are we going to be breaking this up into 2 parts, or are you going to do everything all at once?
No, we're going to hand over to Mark. So hi, everyone. Mark's going to give you the introduction to the company, and then you're going to listen to me talk about the sensor a little bit, and then we're about to go back to Mark. That's hopefully what we're going to do. Non-scripted. We'll go for it.
Awesome. Yeah, that's the way we do it. So are you going to do the demo first, then a little bit of the warm-up?
No, Mark's going to go
okay.
first. Yeah.
Perfect. Glad we got that ironed out. Okay, Mark. We will
okay, no problem. Thank you very much. I'm going to share my screen now. So hopefully everyone can see my screen. Andrea, can you confirm?
Yes, good to go.
Brilliant. Okay. So good morning, everyone. Thank you for joining us today, and we appreciate taking time out to see what we have to offer. There's a screen going. So there's a brief agenda on what we're going to go through today, a bit of history on ANB, overview on the technology, what the product portfolio looks like, a demonstration with Nathan on the products and how it configures and how it can be programmed, and then have a look at the features and benefits of the products, and finish off with a Q&A, but we're happy to answer any questions as we're going through if they pop up in the chat. So if you look at the story so far for ANB Sensors, we're founded back in 2015. We're runners-up in the Wendy Schmidt X Prize competition held off the coast of Hawaii for deep ocean monitoring. The money from there allowed Nathan and co-founder Kay to set the business up, and over the next 3 years, they received various other funding through the European Union with the Horizon 2020 and other innovative awards that they received. If anyone's aware of the Horizon 2020, they'll know how difficult it is actually to realize that investment and the input from the EU. So that's quite an achievement in itself. Through 2020, they received further investment through other partners who came into the business, and all of that development then led to the launch of our alpha/beta product, which is the S series, and that was launched in 2021. We shipped about 50 of those around the globe, and feedback from those deployments really developed and gave the foundation for the OC and the AQ series products, which we launched at the tail end of 2022. So going back about 10, 11 months now, they were launched as a product set and launched as a technology at the beginning of this year. And we actually started shipping the sensors in anger, so to speak, in March of this year. And we're now spinning up to the full specification of the products as we continue to develop the firmware and the feature set within the product. And the feedback we've seen so far to date from when we launched the product earlier this year has really been quite phenomenal. Have a quick look to see how the technology works, and I'm sure that everyone on the call here will be aware of a sensor, for a pH sensor that's available today, glass-based sensor. It needs to be calibrated, and the minute you put it in the liquid or the source for the sensing, it starts to drift. If you see a change in the pH, you're never quite sure, is that a drift or is that an actual change in the pH? And this is where we offer our unique reference tracker. We measure the drift. It's quite simple in what we do. We've got two reference trackers within the sensor. So we measure the drift within the solution, and we also measure the pH measurement within the solution. And then it's a simple math equation, effectively. When we take the two measurements, we subtract one from the other, and then we get the true calibration-free pH reference. And that's really what we do. So we measure the pH, we track the reference drift, subtract one from the other, and that gives us the true pH reading. And that is really unique to ourselves. We never need calibration, we don't drift, and we give you the true reliable data for the pH measurement. Have a quick look at the product portfolio. We've got one sensor. It comes in 4 or 5 different flavors, and those are really different to the depth rating. So we have our AQ series, which are really aimed at the aquaculture system and estuary monitoring, 5 to 50 meter depth ratings. And we have the OC 300 and the OC 1250 going down to 1,250 meters in depth rating. All of the features are the same. The AQ5, the 5 meter, is different in that it has a potted 1 or 5 meter cable. At the bottom there, we're showing the integration kit, the iKit, and that's really for integration with third-party devices such as gliders or submersibles, where people are taking the board set and the transducer and mounting them into the vehicle or the application as required. We have a range of accessories available for the product. We have a DTU, which is the data transfer unit, which allows easy configuration and interface with a PC. So it's a USB to RS-232 converter. It takes the power from the USB and powers the sensor as well. So it's a very simple, allows very simple integration and programming of the sensor. We've got a flow cup adapter, the AQOC FC, bit of a tongue twister there, but that allows integration into flow lines and so on. We supply cables cut to length to suit the AQ50 and the OC range. And then we have the replacement transducers, the AQ ST or the OC ST. There are 4 different units because they are all tested to different depths. So they go from 5 down to 1250. It is the only consumable part within the transducer, and we'll go into that later when they need replacing. So that's a quick overview of the tech, how we are different, how we are unique, the products that we have. And now I'd like to hand back to Nathan for a live demonstration of the product.
Cool.
Nathan, over to you.
Cheers. Thanks, Mark. So hopefully everyone can see us. So I'm going to just give you a demonstration. I'm going to particularly choose the OC300. That comes in a penny case, watertight penny case, where in the system you get the sensor, obviously some grease for greasing up when you change the transducer, and I'll talk about that process in a bit. A bottle opener or an extraction jig if you want to be sophisticated for replacing the transducer. Then underneath the bottom layer, you get the data transfer unit, as Mark said, for hooking the sensor to a USB port of a computer and powering it through there for configuration, and our ablation block for the maintenance that we do require periodically. And I'll talk about how we do that, and Mark will speak about the details of when that's required as we go through the presentation. So I'm going to share my screen and show you how we can configure the sensor. So we talk to the sensor at present through a terminal program. We typically use TerraTerm. Instructions on how to set up TerraTerm for the sensor are given on our website, but we set it up using the serial port, and we use the specification shown here. Particularly the baud rate at the moment is 57600, but you can change that depending on your comms protocols if it's required. If we take a sensor I've already prepared, so this is already plugged into the DTU, I'm just going to turn the sensor on. Not sure if you can hear it beep in there. So it beeps once when it applies power. Sometimes you get a case, a digit on the TerraTerm menu indicating that the DTU is powered and connected to the sensor. And around 10 seconds boot up time, you'll see the splash screen. On the splash screen, it tells you what sensor is. This is an AQ50. It tells you the interface and driver firmwares that are on the sensor. Periodically, we will ask you to update that, and that's downloadable and easily to do through the website. It tells you about the serial number in case there's any concerns with the sensor, you need to report back, and for logging yourselves, the date, the time, and then the mode it's in. The sensor is easy to configure through a menu operation. So we just type menu, and this gives you the various configurations that you can change within the sensor. Version really just confirms the sensor type that you have, re-shows the splash screen. The time allows you to change the date or time based on your geographical location or however you need it to be. The mode is one I'm just going to highlight here. This allows you, hopefully you can still see, let's move that up, allows you to change the sensor from what we call a manually controlled operation to an autonomous operation. In autonomous mode, this allows you to hook the sensor to a battery system, really just throw it in the water, allow the sensor to switch on when I set a predetermined measurement cycle, and go to sleep when it's not measuring. This is for those autonomous deployers where they just have a battery and no way of controlling the sensor. You can program it, configure it beforehand, and then send it. For today's demonstration, we're just going to leave it in manual control mode. So I'm just going to select one, and we get the splash screen re-shown. If I retype menu, we can show the menu options shown again there. The sensor is configured to 232 or 485 outputs and will run, you just plug it into your output and it connects straight away to whichever one it's connected to. So you don't need to configure it for either one. If it's on a 485, it'll work exactly the same as it is on a 232 and you don't need to do anything else. We use a Modbus address system as well for those integrators that use a Modbus type protocol to talk to their sensor networks. And you can change that on this menu by using the Modbus address system there. We have a range of measurement functions. In the interval, that allows you to change how often the sensor will monitor, and that goes from 15 minutes up to every 4 hours at present. We have a scan-O function, which is for the higher salinity conditions greater than 10 ppt, and a scan-F function, which we're currently rolling out and developing the firmware for, which will go to the lower parts per thousand measurement. A scan-O1 function allows you to turn on the sensor, type scan-O1, it will take a single measurement and then turn off. So these are for people that want to poll their sensor, take a measurement, and then turn it off straight away. And that's the way the sensor runs. And you can continually poll the sensor using a scan-O1 type function. We also have the shut down and stop functions at the end, and I'll show you that. For now, we're going to put the sensor into a seawater solution. There is solution in this beaker, even though you can't see it. And we're going to do a scan-O function. So it gives you a feedback that the sensor is now scanning. And while it's taking its first measurement, I'm going to stop the share and talk to you about how we can replace the transducer and how we can maintain the transducer. Periodically on the sensor output, which I'll discuss once we get some data from the sensor may tell you that it requires abrasion, and that's shown on one of the health numbers. And again, this information is available on the website. Using your abrasion block, or really some sandpaper, you can take the surface of the sensor, you can then abrade the surface of the sensor by giving it a good hard abrasion. On the website, you'll see that we can recommend that you put 2 black dots using permanent marker on the top of the sensor's transducer, and you abrade the top quite firmly until those black marks have gone. If we look at the transducer itself, I'm not sure if the definition will come out too well, but we only ever abrade the top face of the sensor and not these 2 side parts here. We only ever abrade the top face. These are our pH sensing elements. On the other sides are our thermocouple, reference elements, and reference checking elements, and they don't require any abrasion. They're perfectly well for long lifetime deployments. After around 20 to 30 abrasions, the sensor may tell you to change the transducer. This is quite simple and easy to do. You can apply a replacement transducer from Aquatic. Basically, all you need to do is not do anything to the unit. This is something that the end user can do. You take the extraction jig or the bottle opener, which hopefully you haven't taken to the pub. You can then pull the sensor out using the transducer out using the bottle opener, and you can simply pull the transducer from the sensor. You can then take a new transducer, locate it using the location system, and I apologize if that's not obvious there on the system, but you can just locate it and it'll pop in there, and then you can just drop it home. I would say on this system, there's no O-rings, so I don't have to apply much force, but on the sensor that we give you, obviously there's no ring seal, so you have to apply a little bit of force just to get that home, but don't be worried about being a little bit brutal with it. It can take it, is what I would say. It's the same with the abrasion. Unlike any glass instrument where you have to be quite delicate with, we recommend quite a hard abrasion when you do this and when it's required. And that's really to take off a good 5 to 10 micron off the top layer that we've got. These pellets are around 2 to 3 millimeter in depth, so they can take quite a few abrasions before they need replacing. Okay, so don't be shy with the sensor, is what we'd always say with it. I'm just gonna now return to Terraturn, and hopefully just going to share my screen where we're getting the first data output from the sensor. So I'm just going to go back and share the screen now. So the data is now being outputted, and hopefully you can see that. Typically it takes around 90 seconds for the first pH sensor to respond. And that's really because when we turn on the sensor and do the first scan command, we're looking at the reference element and we're understanding a reference electrode potential. And we do the checks and validations on that reference potential first before we take the pH measurements, and then we can correct those measurements for any changes that we've seen in the reference element. Periodically, it will do a reference electrode check because this is how we stay calibration free, as we said earlier. The output of the sensor is shown here. We've got the date and the time. We've got the pH of the solution. We've got the temperature delivered in degrees C, and we have a range of other outputs here. In the future, the first 2 zeros will be salinity and conductivity. We're working on that firmware, and we're due to release that in the next 4 weeks is our aim. We have a transducer health number. As you see, the sensors start to degrade with monitoring or measurements. That health number will rise, indicating that maintenance is required through that abrasion that I just discussed. There's 2 other zeros which are for future monitoring, and we have ideas in the future to put other analytes that we can detect with the same architecture into, and the same transducer that we're currently working on in our research and development labs. The final one is just a file number, and you can call the numbers from the internal log of the sensor. So inside the sensor, there's a login system. Basically, this allows you to call that data from that internal log, and you can download it and open it up in Excel. So you can manipulate it quite happily as you want. That just tells you about how the sensor runs. I'm going to try and type stop now, if I can. There we go, without making a typo, which is good. And now the sensor's stopped and it stopped scanning. And that's, in essence, how the sensor runs. It's fairly simple, but we're open to questions and improvements always. In the future, we're looking at developing a graphical user interface as well for various displays of the sensor, and that's something that's very much in their product line. I'm going to hand you back to Mark, who can now talk to you about more of the USPs of the sensor.
Okay, thanks, Nathan. Thank you for that. I've just started sharing my screen again now, so hopefully that's popped up. Can everyone, Andrea, can we see that screen?
Yep,
Okay,
all good.
brilliant. So just like to touch base just on the maintenance required for the sensor. First of all, it requires minimal maintenance, so ongoing costs are really kept to a minimal with the sensors that we provide. We need to abrade the sensor every 15,000 measurements, and that relates to, as you can see on the screen there in the bottom left-hand corner, if we're continuous scanning, today our continuous scan mode is every 23 seconds. The sensor would need abrading every 5 days. Now, it's important to understand that the abrasion can take place in situ, so you don't have to take the sensor, out of the fluid or the water that you're measuring. You can go down, you can scrub the sensor in place, and off you go again. It's good to go. If you're doing a measurement every 15 minutes, that equates to 52 days. If you're doing once per hour, that's 208 days. So, the intervention required of the sensor is really minimal as we go forward. And the costing of the transducer is very low. But again, please speak with Andrea Patrick regards the pricing of the spare transducers. So Nathan mentioned that we have a health status that's shown to the operator. It's outputted via our protocol on the sensor status and also the transducer status. So it will tell the operator when it requires abrading. It will also tell the operator when it requires replacing. Now, we say, after 20 abrades, the transducer then requires replacing. So if you're doing that once every hour, that's over 10 years between replacements of the transducer. So it's a massive time if you're measuring at once per hour, 4,160 days. If you're doing continuous scanning, it's every 100 days. Every 15 minutes, it's over 1,000 days, 1,040 days. But the sensor will tell you when it needs doing. They're intelligent in that respect. You won't have to keep a calculation and, I'm sensing every 15 minutes, how long do I need to go before abrading? It will tell you when that's required. And that's output, whether we're on the 232, 485 in serial or in Modbus. It's all provided to the operator. Very simple to do. Replacement of the transducer is under 3 minutes. As Nathan just mentioned, it can be done by the user. No special tools required. There's 2 cross-headed screws that you need to remove, pop out the collar on the transducer, prise out the transducer, and pop a new one in, and it's good to go. So now we'll have a quick look at some of the features and benefits of the product. So first of all, it's a multi-parameter probe. Today we're delivering pH and temperature. We're about to release conductivity and salinity. So there's 4 parameters from the single probe. And all of those upgrades are going to be provided via a firmware upgrade. And as we go forward, again, just think of this unit. I should have said it earlier, sorry. Think of this unit as it's a truly digital device. It's very different to any sensor that you'll have seen in the past. You upgrade the firmware on your phone, you get new features. That's how we're going to be operating going forward with these sensors. Some of the new parameters that we're looking to introduce, we've got one in work now. It should be coming through in about 12 months' time. That will be on a software upgrade key. That's the plan. So we'll release on the same architecture, on the same hardware you have today. We'll be releasing further parameters. And very soon, in the next couple of weeks, you'll have full salinity and conductivity available. It's extremely easy to use. You don't have to store it wet or dry. There's no fragile components in the unit. So it's very easy to deploy, very easy to transport. We don't suffer from biofouling. As a byproduct of this, of the sensing of charging the chemical electrodes on the pH sensor, we produce a very, very small amount of hydrogen peroxide. Now, it is minimal. There's a very small amount that produced on the faceplate of the electrode, and that inhibits biofouling. The pictures that you can see there, they're taken from a deployment that we had off the coast of Barcelona in the Mediterranean, which is very susceptible to biofouling. As you can see here on the casework of the of the sensor itself. This is our old S-series sensor, but there's a lot of biofoul on the case, but the actual transducer is clean. So you don't have to worry about biofoul with these sensors. It's a solid state device, so it's ideal for remote long-term operations. It's a true digital device, and it's extremely small form factor. You can see there, I don't know if you're familiar with Obscape, another product that Aquatic sell and distribute. This is their wave buoy. We're being integrated literally as we speak. It's being integrated into the Obscape platform today. This is their PTM module. And this is more or less a life-to-life size comparison between a Blue Robotics ROV, which are integrated SUV, sorry, that we're integrated to, and the PTM module from Obscape. And we've been integrated into a number of other third-party products as we speak as well. You've got choice. I mentioned before, we've got 4 options. All provide the same features, but different depth rating down to 1,250 meters, 350 and 5. We pressure test all of the units down to double the depth rating for a very short period of time to make sure we have integrity. The depth rating, we guarantee the units to operate to. And they're integration friendly. You can buy the integration kit. As I mentioned earlier, that comes as a bare PCB set with the transducer. So if you want to integrate it into a glider or an ROV or SUV, you can do so. And we provide all of the protocols, all of the CNC files, all of the CAD drawings are on anbsensors.com, open source, so people can download them and integrate with their products. We've got integration at heart. So we really do try and make it as easy as possible to integrate with the technology, with the products that we're providing. We're very adaptable. It will work in any orientation, in any environment. So if it's in freshwater or saltwater, in any orientation. Today you have to say scan O or scan F. Scan F is coming in a couple of weeks. But when scan F is delivered, it will just automatically sense whether it's in freshwater or in saltwater. You won't have to tell it what you're working in. It will automatically recognize that and adapt itself to that particular operation. It can be stored wet or dry. So you've got no tricky storage requirements. So it's very simple to store and very simple to transport. The units themselves have got onboard storage. So they do become a data logger, and they'll store over 15 million readings for the parameters that we're looking at here. So that's pH, temperature, conductivity, salinity. Over 15 million readings of each will be stored onto the integral memory. You can go online, connect to the sensor and download that information. You can't pop the storage out. That isn't available in this, but it is very simple to retrieve that information. It's extremely robust. We have digital output on RS485, RS232. We're in serial mode or in Modbus RTU. So it's very easy to integrate to. And again, all of our protocols are online at anbsensors.com to download. Extremely robust. There's no fragile components within the units. There's no glass to break. You can knock them around and they won't shatter, they won't break. So it's very easy to transport and very simple for handling. They're very flexible. You can program units, as Nathan mentioned before. You can program them to operate as required and deploy them, and then they'll go off and operate as requested. Automated, so you immerse the units in water, it automatically senses that and will start operating in the way they've been programmed. Nathan mentioned that we are reporting back on the sensor status and the transducer status, so we are intelligent. We're constantly monitoring ourselves, and if there are any issues, they'll report that information back to the operator and say, look, there's some intervention required here. My transducer needs replacing, or it needs abrading, or you need to have a look at some of the operation. So we do feedback that information. You're not worrying all the time. Have I got correct data? Is it operating correctly or not? We'll tell you. And it is truly disruptive. It is unique to ANB. There is no other technology available on the market today. It is unparalleled, and it is truly a disruptive technology that we're now bringing to market. And it's tested. I mentioned before that it's been deployed over 2022 in 50 deployments around the globe. So we know that the units are performing as required. and they're highly affordable. The upfront ticket price of the units may be slightly higher than a glass-based sensor today, but we've got very low maintenance, and we're delivering up to 70% cost savings against conventional conventional sensors, I should say, sorry, that are available on the market today. And last but certainly not least, we're calibration-free. I think we've mentioned it a couple of times during the presentation. We don't drift. We require no calibration for the life of the sensor. Even when you replace the transducer, there's no calibration required. That really brings me to the end of the presentation. I'd like to hand back there to Andrea to pick up, or Nathan, if you have any other comments that you'd like to make. But again, thank you for your time, and hopefully that was informative for you all.
That was great, Mark. Yeah, I'm like, hey, what can I ask? I don't know. So if anybody, like, that was super thorough. That was I really enjoyed that presentation. I haven't seen that version, and it was excellent. Does anybody, now we're at 12:35, does anybody have any questions for Mark or Nathan regarding specs, operations, deployment procedures? I'm just looking for hands up. You mean they did that good? Oh, here we go. I have one from Jan. Will the instruments be able to communicate with third-party data loggers, Sutron, Campbell Scientific, over SDI-12 protocol?
Not currently. It's something that we're looking at. Currently, it's all 232.485 protocols, communications. We are looking at putting analog outs on the sensors going forward. And for us, it's a board change where we configure a sensor with digital or analog out. So it's something that we are looking at, but it's not currently available.
Good, thanks, Nathan. I know some of the Campbell Scientific will take obviously RS-232, so that will work. But I know SCI is probably SDI-12 is one that's interested in water quality monitoring, maybe utilities, that sort of thing. Another one from Caitlin is, can you please share more about the data quality? What pH scale is it reporting on? What is the uncertainty, etc.?
Cool. Yeah, so at the moment we've calibrated it to the MBS scale. We're currently running up spectrophotometric measurements to take it to the total. So that's what we're working on. The accuracy is around the 0.05 pH units in the oceanographic area. We may lose some of that accuracy as we go to very fresh waters, but it's at 0.05 for the oceanographic, and that's where we're trying to set a standard to be. As I say, we're calibrating it to glass electrode systems, calibrated glass electrodes, which we calibrate daily, and then we're working on the spectrophotometric measurement to take it to the total. But as you get the sensor today, the numbers that you see are very much on the MBS scale. But we'll give it as a second output. So as I mentioned earlier, one of those zeros that we currently populate on the output, we'll convert that to a total.
Awesome. Thanks, Nathan. Just on the same line from Janet Reimer, do you have interval consistency data that you can share, for example, sensor results compared to spec total scale pH from laboratory data?
Yeah, we've got some. We can share that after the presentation. I think that might be useful.
Perfect. Perfect. Okay. So we've got some from Michael Twist, biofouling reduced by H2O2 production, evidently, so hydrogen peroxide, but can the abrasion maintenance be accomplished using an abrasive wiper for remote operation?
Certainly. So we haven't tested, but certainly an abrasive wiper is something that can be done. It's something we discussed with various integrators and companies that want to do it that way. We're really looking at taking a few microns off the surface. So it does need to be abrasive. It's not a sort of a wipe across an optical sensor, which you might get for the DO, but it's an abrasive removal. But it can be done underwater, as Mark said, in deployment, and that's easy enough done. So we don't see that as a big issue, and it's certainly something that we'd either work with partners doing, or if you want to do that yourself, that's something you can do. And we work with you on trying to configure it and getting the right abrasion technique as well.
Okay, awesome. So have you given any thought to using like a wiper from another manufacturer, as far as like maybe even partnering with them? And it says, could you use the abrasive disc instead of a bristle brush on the wiper?
Yeah, I think so. Yeah, we've spoken to some. We haven't gone any further than initial conversations, just because our aim is to get all their firmware out the door on that side of it and get that developed for the freshwater and the salinity conductivity measurements out. That's their drive, because that's what we want to fulfill first. And then going behind that is the maintenance and making that as easy as possible for everybody. The data, the sensors are actually done in Barcelona. They were biofouling free, but periodically a diver went down and actually abraded the surface as well. So it was done underwater and in situ. So you really just need either the abrasion pad on a wiper type system, and that will work.
Yeah, excellent, good. From Eric Lindstrom, we have, can you elaborate on removal of trends in the sensor data? How will we study environmental trends?
So the data that we collect, I think pH is one parameter among many, obviously, and it is a key parameter. The data goes every 23 seconds. We are looking at reducing that down to every 8 seconds. So if you're on a profiling instrument, then our aim is to make it as quick as possible. There are limits to how fast we can go without losing accuracy. We believe 8 seconds is achievable. Again, it's through a firmware upgrade. You wouldn't need to replace the sensor or anything like that. But it's on our roadmap, I would say, near the end of the year to reduce that down. And I think that'll help with some of the trends for the profile emission. I guess if you're on a buoy system, your measurement rate, we go from 15 minutes up to every 4 hours. So you can look at those longer term trends. And the accuracy is good enough for a number of applications if you're near sort of effluent pipes and stuff like this. Ocean acidification is reasonable, but it's obviously not the higher resolution that you might get with some optical sensors.
Right. Great. Jan has another question. How does the sensor handle being periodically encased in ice or exposure to frazzle ice? And then I'll ask you that. And he said, likewise, how would the electronics handle the power cycling caused by the dying power supplies in the remote stations? I think
Okay.
we've got two-part question.
Yeah, no, that's fine. So we've actually put the sensor in a freezer and put it in ice and then defrosted the ice off it. And we didn't see any degradation on the performance, I would say. So we've done those types of tests. The sensor will pick up a signal. It will also tell you if it's below the minimum that it requires for a signal. So it will flag it if there is an issue in those icy to fresh, the melt stage. So it needs a certain amount of liquid flow to get it going, so it requires that. In terms of power cycling, power dying, the sensor will go into a graceful shutdown. One of the issues that we've solved is looking at the internal login, which is on an SD card, to make sure that's not corrupted if it's gently power cycling. And we've got that now, so it's robust and it will shut down below a certain cutoff voltage. So.
Nice. And I think part of your integration with Obfuscate with their wave buoy and their PTM, which is a power telemetry module, those are solar powered, and they power lithium-ion batteries, or they're regular batteries, and those provide continuous power and will take the data and send it to you to a free data portal as well. So with that integration with the ANB sensor, you can leave it out there indefinitely until you have to go and do a cleaning for it. I think that was part of your reasoning of collaborating with Obfuscate as a partner.
Definitely. Yeah. No, that's a great way of deploying the sensor.
Yeah, Mark, did you want to comment on that partnership with Obfuscate, or I just saw you unmute yourself?
Yeah, no. That's I think you hit the nail on the head there. They've got a great it's a free portal, data portal that they provide. So if you've got 10, 20, 50, 200 of the units deployed around the globe, all of the information will come back to the data portal, and you can track and trend the data as it comes into your portal. So it's a great collaboration that we've got going with them, and they're physically doing it as we speak. We're speaking with the guys over in Holland today.
Yeah, inexpensive as well, so it suits back in the day, it would suit the freshwater people as well. I know sometimes their budgets are smaller than the oceanographic people. I may have stepped on some toes, but I'm sorry about that. Another question we have coming in is there any routine maintenance that requires users to send the instruments back to the manufacturers or vendors?
No, not as far as we can tell or foresee.
Yeah.
Yeah.
We like to say set it and forget it.
Yeah.
It's worth mentioning there as well that it is a 2-year warranty provided with the units as well.
Oh, great. Good. Yeah. That's a great thing. But yeah, you don't want to see them back in your at your place at all, is the whole point.
At all, no.
Michael, thanks, Michael. Back in the day, I'm probably dating myself. Back in the day, you know, some of the budgets were a lot smaller in the freshwater. One of another question that came in here is, can it be battery powered underwater? Do you have any sort of opportunities for that?
Yeah, so we actually sell a battery pack as well to go with the sensor. It's run off a rechargeable lithium-ion battery. Actually, within that battery pack is a smart monitor, so that actually you can configure the sensor. The sensor will tell the battery pack its operational conditions, and then it will run into its best performance in terms of power management. So we've actually built that into the sensor. In the battery pack, it will have, we haven't got it yet, but it will have a login system as well. So you'll be able to double check the data either off the battery pack or off the sensor itself. So we've got that as an available product.
Okay, do you have a Maxable cable length, do you think, that you guys provide or can be provided?
So it's a serial comms. So, you know, we go 10, 20 meters. We've done longer, but, you know, 10, 20 meters, we can provide those.
If it's on its own, otherwise it can just be on a mooring in a system.
Yeah.
I do have another question here. Can pH calibration standards be used for testing the sensor?
That's one of the challenges. The beauty of it being calibration free means that it doesn't like standard buffers, IUPAC type buffers. We are looking at workarounds around that where you can report it back to a standard IUPAC buffer, but that's presently not available. And I can go into the intricacies of why that's the case. It affects our reference checking element, which has been tailored for the oceanographic freshwater conditions. When you go into the higher buffer conditions that you get with IUPAC standards, that impacts our reference checking element. So that's why we don't do it in those standards.
Yeah, good. I know I've had a few questions about the DTU, the data transfer unit. Is it used for field deployments? Like,
it can be. It's not watertight, the DTU. It's not watertight, so that's one issue. But you can put a long cable on it and run it from there. It's allow you to pretty much put it onto a laptop and run it off a laptop. But you can certainly it can come off a 5-volt power supply if it's in autonomous mode, off the USB connector, and power the sensor off of sort of a USB battery pack as well. I don't know how many people have actually deployed it in a field location. I know some people have put it in their lab locations where they're looking at monitoring tanks, but not actually in a field location. As I say, it's not watertight.
Yeah, that makes more sense. Because there's like an 8 gigabyte SD card in the unit, right? That you can collect and download the data when you get back to the lab, or if you want, you can have the D2. Because we do have some clients that take their laptops in the field to, I think that's scary, but you know, to do a deployment with the D2, I wouldn't want to get any
put it in the bag.
Fall off my canoe. Yeah. Fall off my canoe. Awesome. Does anybody else have any other questions regarding to elaborate on anything else? Feel free to unmute yourself or keep popping them in the chat. What do we have from Jan? And Jan is from Credit Valley. I believe they're conservation. They're in Ontario. So will it be possible in the future to see ion selective electrodes for chloride or nutrient monitoring?
Potentially chloride, but that's not something that's immediate, I would say. We're not looking at the nutrient side for additional sensors. As Mark said, our aim is to manipulate the sensing chemistry of the transducer as much as possible. And there is a set number of analytes that we think is achievable doing that. And that's what we're looking at. I won't say the ones that we're looking at doing, just because I don't want to overlay expectations just right now. But certainly, yeah, we're looking at adding one more at least over the next year, but not nutrients.
Okay, good. Yeah, good. Michael Twist says he's from Ontario as well. Chloride would have a big market in the freshwater realm.
Okay, that's good to know.
Good to know.
That's very good. Yeah.
That's good, because I was going to ask you if you could share additional parameters, but I will not press you on those. But can you share if you have any plans for like a handheld or any sort of like smartphone apps?
Potentially, we're not looking at the wireless comms side to get to a smartphone, I would say. I think a roadmap for our comms is very much obviously digital, going on to the analog sort of SPL12 type systems, and then looking at where we can take it into the IoT system. Because we require power, we're always going to have to be plugged into something, and we always rely on that to deliver that end of it. I would say for the smartphone side, we are looking at GUIs for laptops, so you can run the sensor through that. I don't know, Mark, if you want to add anything to
that. The GUIs the GUIs work in progress. That's going to be a browser-based GUI. We're expecting to release that next month, maybe going into October, but it is very, very close. That'll be a very simple, clean user interface to give the depiction of the sensors that we're sensing, and so on. We are integrating with a number of free space providers. We mentioned Obscape here for 3G, 4G, 5G connectivity, but we're in discussion with about 5 different providers at the moment who have satellite backup to their mobile comms as well. So if 2G fails, or the other way around, if 5G fails, it goes to 3, to 2 fails, it'll go onto your satellite network. And there's 4 or 5 people we're talking to on that to give you free space connectivity. We are talking to one other provider who are an IoT based solution, but that's quite specific to aquaculture. It's not in the open market. But all of those, I mentioned before, the whole product has been designed around ease of integration. So if you come along with an application and you want to use a certain Bluetooth, Wi-Fi network, satellite network, speak to us, and we'll happily speak with them. You need to go on our website. All our protocols are on there. It's open source. There's no, nothing's hidden there. So it's ease of integration. That's what we're all about.
Yeah, no, for sure. And like you said, with the Obscape, they have that data portal that will go to your laptop or your phone, so you could be anywhere watching your data from your cell phone, smartphone, with your on your, because it goes right to your any apparatus that you want it to go to.
And that is such a powerful feature that Obscape deliver, and it really is, and it's free of charge service, and it really is a powerful solution they give there.
That will be our next webinar is with Obscape, so maybe we'll invite you for spotlight.
There you go.
Yeah, awesome.
Live from Cape Town.
Exactly. I don't know who to ask this to, but can you use more than one sensor with one laptop? Like if you were to use like one DTU, one laptop, can you have like 4 sensors?
So it's DTU sensor. You can have 4 DTUs to one laptop. Powering 4 sensors. You can't run 4 sensors off one DTU at the moment. So you need additional DTUs, but you can certainly run it. So we use a COM port extender on our laptops, so we can run up to 8 sensors off one laptop with 8 DTUs.
Okay. Do the sensors have analog output?
Not presently. It's on our roadmap to deliver.
Yeah, we just come back from Aquanor on that one, a big aquaculture show in Norway, and that's quite high on my request now. The 4 to 20 milliamp analog output.
Awesome. Jan has another question. Are there any solutions that the sensor may be exposed to that damage to the sensor chemistry? We occasionally see high sediment or hydrocarbons from spills in our freshwater rivers.
I would say suck it and see in some ways. We can't test everything that we want to do in the lab. So there may be situations where that may happen, and I can't imagine hydrocarbons doing that. But yeah, I'm sure there's some, we've tailored it, as I say, for the oceanographic water environments. We know in heavy industrial effluents, it may not work. But so most freshwater pollutants, I think we'll be okay with, but we can't know everything until we try it. So sorry, Mark, I was going to say we're happy to have samples sent to us to test it beforehand to give confidence. We like collecting information and data, so that's where we're at. In the future, not right now, just because around supply chain, we could send sensors out for testing in those environments as well. So we want to learn as much as possible to make the sensor better for everyone. And that's part of, as Mark said, everything's open source as much as possible, but also the information that we gather from the tests, the trials, and where the sensors are placed, we also put back into the development cycle.
Yeah, I was just going to mention there as well that we've got trials starting now or in the next couple of weeks in some heavy wastewater applications and in some mining tailings dams and so on. So areas that we're not aware of, we haven't tested it in that, but we're quite confident we get the sensors in there. We can go into a retrieval mode for the data that's retrieved from those locations. And by looking at that raw data that comes back, we can then fine tune the performance of the sensor, and we can send new firmware. Again, think of it as a phone. Upgrade your firmware, you get new features, and that's what we can offer by taking that raw data, looking at seeing what we can provide and how we manipulate that data coming back to operate in the certain liquids that we're working in. As Nathan rightly said, we can't test everything, and we're relatively new coming to market. We've come from the oceanographic side into water, and there's loads of opportunity applications that we're just dipping our toe in the water, so to speak, to trial the operation and performance.
Mm-hmm. No, that'll be interesting. Yeah, that'll be interesting to hear about the feedback on that. A question, any issues with very low conductivity deployments?
So that's kind of where our firmware is sat at the moment. We're very much working on the low salinity. There's going to be a cutoff at somewhere. How low is the question, I guess. We've down to around 100 millisiemens, and that's okay. 100 millisiemens, that's fine. I think just checking my units there. And then we'll see how low we can go below that, I would say. As Mark said, it's firmware and tuning the parameters, how we drive the signal to get the sensor out. So that's pretty much where we're at the moment. And so that firmware is not available because we're working with some strategic partners in optimizing it for those very low conditions. One of those is actually snow melt, so that's pretty much as low as you can go, I guess. And we're working with them to see if we can drive it down to those levels.
Yeah, fantastic. Yeah, I know it's constant development.
Yeah.
But you guys are great at handing out the firmware on a regular basis. Any other questions? Nathan's getting his workout today. We're just prepping you for your talk. And I did say I was going to put his accolades in the chat, so I'm doing it now so you can read them. You don't have to read them, Nathan. You're good. But if there's any further questions, I guess one would be like the connectors that you guys use. If somebody needed to use something else for their systems or operations, are they swappable, or can you swap them out? I'm sure that's probably some sort of extra charge for that, but
there will be a little bit of extra charge. So we either give it as a pigtail cable for the shallow water AQ5 or subcon connected for the deeper 50 meter below. So that's our standard. Not saying that we can't do others. We can swap out the back end of the sensor. So which is pretty much, there's a part here which can be pulled out and we can remachine this for a different connector if required. So we can look at that, but we can supply a pigtail one for the shallow water ones as well.
right. And just to be clear, the OCs, the OC300 and 1250 both get sent with the DTU. And the AQ5s or the AQ5 gets sent with either a 1 meter or 5 meter, depending on what you want. And the AQ50 does not get a DTU. So you have to order your cable or whatever else you want to integrate it with. But those are mostly like estuary or coastal people that want to put it on a buoy or a buoy, same thing, potato, depending on where you're from.
Yeah.
Good.
That's right.
Good. Okay, so if there are any other questions, please feel free to unmute yourself or keep plopping them in the chat here. I think it was a very, very well put together presentation, so it was very easy to follow. And I think you did a very good coverage of all the bases. Easy to use, set it and forget it. I think that about covers it. What covers it. So if nobody else has, we're just about at the hour here, which is great. So hopefully you guys have eaten your lunch while you're watching this presentation. Jan says thank you. Michael says thank you. And yeah, and thank you everybody for your time today. If you want to stay on and ask any questions that you can ask while you're on here, feel free to. Or Nathan, maybe if you want to even just put in your email address if anybody wants to email you directly, or I could put it in there, and feel free to send Nathan questions you may have. So let me just do that. You guys can get his, or you can find it on anbsensors.com. Sorry, that sounded like an infomercial. So here is Nathan's email address, and I just want to thank everybody for their time. There you go. And I'll put Mark's in there too, because we don't want Mark to feel left out. We get in trouble. We get in trouble.
You do get in trouble.
Yeah. All right. So there is Nathan and Mark's email addresses, and you guys have ours. And for those of you who went under Patrick Sanders' name today, we appreciate that. He appreciates that. But thank you all for your time. So if anybody doesn't have any other questions, you're dismissed. So thank
you very
everyone.
much.
Thanks,
Thank you for
thank you
organizing.
guys. Yes,
Thanks.
and thanks ANB Sensors very much for your time. We appreciate it. We know it's 7 o'clock your time, so you're dismissed too.
Oh, thank you.
Thank you much.
Cheers.
Take care.
Cheers, everyone. Cheers, cheers.
Bye. Bye.
Bye.